This is exam 2 review. Fill the blanks. If tangent x is equal to 1.5, that means tangent negative x will be equal to negative 1.5, because I basically can write tangent negative x as negative tangent x, which is equal to negative, and I know the value of tangent x is 1.5, so it's going to be negative 1.5. So sine x is equal to 0.8, so sine negative x will be negative 0.8, because sine is odd, so the negative will come out, and it's going to be minus sine or negative sine x, and I know sine x is 0.8, which is going to be negative 0.8. Cosine x is 0.7. What is cosine negative x? I know that cosine negative x is similar to cosine x, which is 0.7, so that doesn't change because this is an even function. I said sine is an even function, it's an odd function. Tangent is an odd function. If tangent is negative 2.5, then tangent negative x is negative that, which is positive 2.5. If secant negative x is negative 2.4, then secant x is equal to the same number, negative 2.4, because I know that secant negative x is equivalent to secant x. Secant is even function. Cosecant negative x is equal to 8.3. That means cosecant x is equal to negative cosecant negative x, and that is negative 8.3. Now we need to determine the following functions if they're even, odd, or neither. Any addition of two even functions is going to give me even. Any addition of two odd functions is going to give me odd. If I mix odd and even, then it's going to be neither. If I multiply two odd functions, I'm going to get even function. If I multiply an even function with an odd function, I'm going to get an odd function. Okay, so this is kind of gives me an idea on how to start working on these problems. Now, if I scan and determine whether the function is going to be even and odd, that is going to help me prove that algebraically. Now, I know that cosine is even. If you square it, it's going to be even. Sine is odd. If you square it, it's going to give you even. So even minus even, I think this is going to be even, or I believe this is going to be even. Let me prove it algebraically. To prove it, first replace each x with negative x. So f of negative x is equal to cosine square negative x minus sine square negative x, which is I can simply write as, make it a little bit bigger here. I can simply write this as cosine negative x all squared minus sine negative x all squared, which will give me cosine negative x is cosine x minus, and then sine negative x is negative sine x, and that will give me cosine square x minus sine square x. And this is exactly the original function, so this is equal to f of x, which means it's even. So if f of negative x is equal to f of x, the function is going to be even. Now let's go to the next one. I know that sine is even, sine is odd, and secant is even. And I know that if I multiply odd with even, I'm going to get an odd function. Let me prove it algebraically. So we're going to say g of negative x is equal to 2 sine negative x. Replace each x with negative x, secant negative x. This is equal to 2 minus sine negative x. Sine negative x is negative sine x. Secant negative x is secant x, because this is an even function. So I can rewrite this as negative 2 sine x secant x, which is exactly negative g of x. So since g of negative x is equal to negative g of x, that means this function is odd. H of x is equal to 1 plus secant x tangent x. I know 1 is even, all of the constants are even. Secant is even, and tangent is odd, meaning this multiplication is going to be odd, but this is even. If I combine even and odd, I am going to get neither even nor odd. Let me prove it algebraically. H of, let me make a little bit smaller here. H of negative x is equal to 1 plus secant negative x times tangent negative x, which is equal to 1. I know secant negative x is positive secant x, but tangent negative x is negative tangent x. Notice how this is a multiplication. Please do not confuse this negative sign with the minus sign. It's not minus sign. So I have secant x times negative tangent x, which will give me 1 minus secant x tangent x. Notice this is not equal to h of x, which is the original, and it's not equal to negative h of x. So this is neither even nor odd. Okay, this one right here. 5 is even, secant is even. I know this is going to produce an even function. Let me prove it. K of negative x is equal to 5 plus 3, secant negative pi over 7x, which is equal to 5 plus secant negative something is secant that something. So it's going to be the positive 3 secant pi over 7x, which is the original function k of x, and that means it's even. E, L of x is equal to tangent square x plus 15. Tangent square, although tangent is odd, but tangent square is even, plus 15. 15 is even. That means L of x is even. L of negative x algebraically equals tangent negative x, and I can write the square over all, plus 15, which is equal to negative tangent x all squared plus 15. That is the same as saying tangent square x. When we square the negative, it becomes positive, and then tangent square is tangent square x plus 15. And this is exactly L of x, which is the original function, which means this function is even. F, it says here m of t. We know that it's m of x, it's just a typo. I have even function, and then I have odd times odd. I know these two odds are going to produce even. Odd times odd gives even. So even minus even, this combination here, this multiplication is even. So even minus even is going to produce even. Let me prove that algebraically. M of negative x is equal to cosine negative x minus sine negative x times tangent negative x. Okay, so this becomes cosine negative x. Cosine is even, so it's going to be cosine x minus, and then I'll put the negative here. Sine negative x is negative sine x times tangent negative x is negative tangent x. So this is cosine x minus negative times negative is positive, so that is positive, negative, positive sine x tangent x, which is the original function m of x. And this means it's even. M of x is even. All right. We're going to use the calculator to find the following. Secant 25. Notice that most of the calculators don't have secant. So we're going to say we need, secant is 1 over cosine 25 degrees. So this is what we're going to plug into our calculator. Let me pull my calculator really quickly. Make sure your calculator is in the degree mode. So the mode, switch the mode. I should turn it on first. And then the mode, it's in radian mode now. So I'm going to switch it to degree mode and then click enter. All right. Now we need 1 over cosine 25. So 1 divided by cosine 25 degrees is equal to that number. I'm going to round that number to 4 decimals. So the answer is going to be 1.1034. Approximately 1.1034. Similar, I am still in the degree mode, so I can do the number C. And this is cotangent, so this is 1 over tangent. Negative 212.5. Here, I'm going to say 1 over tangent. And I will use this negative at the bottom that has parentheses. Don't use the minus sign, please. This is negative, this is minus. Negative 212.5. And that will give me approximately negative 1.5697. So round it to 4 decimals. This is approximately negative 1.5697. And then I will switch to a radian mode since I have radians here. So I'm going to switch to radians mode. Here is the mode. Down, radian, enter, clear. And then I will type cosecant. I don't have cosecant here, so cosecant is equal to 1 over cosine, 1 over sine. All right, so this is all right, let me continue a little bit. Let me wait. Where did I go? All right, so this is 1 over sine 3 pi over 7. So this is what I'm going to enter into my calculator. Here's my calculator right here. I say 1 over sine and then 3 pi over 7. So 3 and pi is here, so second pi over 7. Enter. It's approximately 1.0257. Similar for secant, so it's 1 over cosine, pi over 6. Again, radian mode. Clear that. 1 over cosine. 1 over cosine, pi over 6. Pi divided by 6. 1.1547. Okay. Okay. And then the next question, if you have cosecant t is equal to negative 3.4, we need to find the value for t and x and beta and gamma and theta and t. Okay, so here we're going to use the inverse functions. We know that cosecant is 1 over sine, so we're going to say 1 over sine t is equal to negative 3.4, which means if you flip both sides, you're going to get sine t is equal to 1 over negative 3.4. If you want t, we know that t is equal to the inverse sine of 1 over negative 3.4. So again, we need it in a degree mode, so make sure that you put your calculator in a degree mode. And then we're going to say sine inverse, so second sine, and then 1 over 1 divided by negative, use this negative here, don't use the minus sign, 3.4. Which is equal to approximately negative 17.11. Since this is in degrees, I'm going to round to 2 decimals. So this is approximately equal to negative 17.11 degrees. Okay. Same for secant. So secant is 1 over cosine. X is equal to negative 0.958. If we flip both sides, we get cosine x is equal to 1 over negative 0.958. If you plug this into the calculator, you will notice that this number is actually less than -1, which means this does not exist because we know that the domain for the range for sine and cosine is between -1 and 1. So since this is below -1, it's -1 point something, we know that it doesn't work. Same here. Notice how sine beta is equal to -2.46. We know that sine cannot be less than -1, and this number is way less than -1. So it's way below -1. It's out of the range of sine beta, and that's why we know that this does not exist either. Okay. This one, same. We know that 4 pi over 3, that is 4 times 3.1415 over 3, is going to produce something that is bigger than 1. So, so we're going to say this does not exist either, because cosine cannot be bigger than 1, which means it's out of the range of cosine, and we can't find it. Tangent and cotangent, the range is from -infinity to infinity, so it's okay to see 2 here. We know that cotangent is 1 over tangent theta is equal to 2, which will lead us to tangent theta equals, let me just remove it because it's out of the frame. Okay, so we know that tangent theta is equal to 1/2, and when in theta, we can plug that into our calculator. So we're going to say tangent inverse. So second tangent of 1/2 is equal to 26.57 approximately. So I'm going to say here theta is equal to tangent. Here, I'm going to write it here. Theta is equal to inverse tangent of 1/2, which is approximately 26.57 degrees. Cosecant is 1 over sine t is equal to -2. That means sine t is equal to -1/2, and t is equal to inverse sine of -1/2. If you plug that into the calculator, you're going to get -30 degrees. Okay. Now, which plot here is 3 sine x, and how did we know? First of all, I'm going to identify all of the plots that are sine. I see that B is sine and A is sine, but D is not a plot for sine. This is cosine and this is sine. So now we're going to determine which one exactly is 3 sine x. We know that 3 is the amplitude, so I'm just going to measure the amplitude here. The amplitude here is 1. The amplitude here is 2. And the amplitude here is 3, which means the correct answer is going to be C. It looks like sine, and it's also got the correct amplitude. Based on the graph above, determine the amplitude, the midline, the period of the function, then write a sinusoidal function equation for the graph. The first thing always I look for is the midline. I see here that the midline, it's not this line and it's not this line, it is this line. So I'm just going to draw the midline here, and I'm going to say the midline is -2. Okay. Now, another thing I notice is if this is the midline, this is my new origin. That means the sinusoidal graph starts from 0, goes up, and then goes down, and then goes up. This looks like a sine graph. So I'm going to say I will use this equation. A sine bx minus c plus d. That is the general form for sine. The amplitude is 1, 2, 3 units. So the amplitude is 3. And the period starts from here, ends here. This is 1 period. That means the period is 2. Now, I need A, B, C, D in order to build this equation. A comes from the amplitude, so A is equal to 3. The B comes from the period. We know that the period is equal to 2 pi, because we're working with sine here, over B, which is equal to 2. So I can find B here. If we switch these together, we get B is equal to 2 pi over 2, which is pi. So B is equal to pi. Okay, B equal to pi. a is equal to 3. I notice that this function didn't move to the right or to the left, so that means I don't have a horizontal shift. As a result, c is equal to 0. The vertical shift, the graph of the function went down 2 units. D is -2, which is the midline as well. Now I can write the equation. This is equal to y equals to 3 sine b is pi x, c is 0, plus d, which is -2. And that is the final equation. Again, we will do some identification here first before we begin. The midline is still the x-axis. That means d is equal to 0. I don't have any vertical shift. I notice right away that the amplitude is equal to 3. So a is equal to 3. This looks like a sine function because it starts from the origin, goes up, and then goes down, and it goes up. So this is a sine function. So I'm going to use this formula. Y equals a sine x, bx, minus c plus d. Now, the length of the period, I see on the other side, if I can measure this length, this is an entire period. So this length from here to here is 6 units. So I'm going to say the period is 6. Period, which is, since I'm working with sine function, it's 2 pi over b equals 6. So I can come up with b. If I switch these, I get b equals 2 pi over 6, which is equal to pi over 3. I have a, b, I need c. Notice how the graph didn't move to the right or to the left, because I can recognize that this point is at the origin and it's a start point here. So c is equal to 0 because the graph of the function doesn't have a phase shift or a horizontal shift. Now I'm going to plug everything into this equation. I will have y equals 3, the amplitude, sine b pi over 3x minus 0, and then plus 0, which is the amplitude, which is the vertical shift. So this is the final version of the equation. Here, notice how the midline is still the x-axis, so d is equal to 0. I can recognize that right away. And because the question tells me that the graph of the function crosses the point 1 and 0 and -5 and 0, I can only assume that. Well, some of you will see this point right here and they will say it crosses at -2 as well. I am not 100% sure because it's not mentioned here, so I'm not going to go with that. With that assumption, I'm just going to go with this assumption. So because this is one of the points, I am just going to draw a vertical line at that point, because this graph of function, it looks like it's a sine function, but it was shifted somehow. So if this is the new y-axis, I notice that the graph, it starts from the 0 or the new origin, but it goes down instead of going up. So it could be still sine because the other side looks like sine exactly. And I can tell it's a sine, but since it doesn't go up, it goes down. I know that the amplitude is going to be negative. So my amplitude here, A, is usually it's the absolute value of, in this case, -3. I know the amplitude has to be a negative number because the graph went down, it didn't go up. I have A, I have D. The horizontal shift, if I determine this horizontal shift, it moved to the right 1 unit. That means C over B is equal to 1. Now, I need to determine B in order to determine C, and I know I can find B from the period. The period for this function is, I can measure from this point to that point. That is 1, 2, 3, 4, 5, 6 units. So the period is equal to 6, which is equal to 2 pi over B, which will lead to B being equal to 2 pi over 6, which is pi over 3. So B is pi over 3. Which means C is equal to 1 times B, which is B, and that will be equal to pi over 3 as well. So I multiplied this function like that. I get c is equal to 1 times b, which is pi over 3, and I found it from the period here. Now I know this is a sine function, and that's why I treated it this way. Now it's the time to write the final answer. So I will use y equals to a sine bx minus c plus d. I know that a has to be negative 3, sine b is pi over 3, x minus pi over 3, which is c, plus 0. So this is going to be the final answer, or the equation for the graph of this function. For question number 7 and 8, I am not going to graph because the period is weird and it's going to take a lot of work in order to get it right on here. If you plot it on Desmos, you'll see what I'm talking about. So I'm just going to find the amplitude, the period, the horizontal shift, and the midline. Now notice one thing here. Notice how the 7 was pulled out. So if it makes you feel more comfortable, just distribute this back in and you will get 5 sine 7x plus 21 plus 8, because it's easier to compare to the formula we have, which is a sine bx minus c plus d. So the amplitude, we know the amplitude is 5. The period for this function, since we're talking about the sine, it's going to be 2 pi over b, and b in this case is 7. Why did I write b here? This is, oh, I'm comparing, okay. Yeah, bx. So b here is 7, so I'm just going to divide by 7. You see the period is weird, so graphing it is going to be a challenge. And then I noticed that c is equal to negative 21, because this is plus 21. I need to match it with the formula, which is minus c, so I can rewrite this as minus negative 21. So I get c is equal to negative 21. The horizontal shift is c over b, which is equal to negative 21 over b, which is 7, which is negative 3. So since it's negative, that means it moves to the left 3 units. Okay. The midline is d, which is 8. That means the graph moves up 8 units. All of these numbers are hard to graph, so I'm just going to skip that part. Same here. So here I don't have to distribute anything. This is A, this is B, this is C, this is D. The amplitude is 6. The period is 2 pi, since I'm dealing with sine. 2 pi over B, which is 5. See, the period is weird. Horizontal shift to C over B, which is equal to 20 over 5. That is 4 units to the right. And then the midline is 3. That means the graph is moving up 3 units. Now, this is kind of a little bit easy to graph. I'm going to stop this video here because it's just getting too lengthy, and then I will continue in part 2.